Welcome back to this playlist. In this video we will talk about the state machine, why we use that, what's the theory behind the state machine, and then we will create a state machine and then abstract state. So before we code it, let's get more information about the state machines. If I go to Wikipedia, I can find this page about the finite state machines, and the state machine is described with this theory. Of course, it covers more stuff, but we are interested in the finite state machine. So finite state machine is a well-known and described programming pattern, and it can have a number of applications, but in this case we will use that to control our hero. So let's see. It says that a finite state machine, it is an abstract machine that can be in exactly one of finite number of states at any given time. The finite state machine can change from one state to another in response to some inputs. So in our case, we have a keyboard inputs, and when we click right, left, or up, we will go to one state or the other. They call it a transition. So for example, when we are in idle state, and if I click up on my keyboard, my state machine should do something in response to that input. So it will do a transition to jump state. Let's scroll a little bit down. So for example, they give a simple mechanism that can be modeled by a state machine. So it's a turn state. These things, you can see them on subways or other things, and they describe it with this chart. So the turn state can be in a lock state, and it will be in a lock state unless you push a coin. When you pay for that, it goes to unlock state and will be in unlock state until you push the mechanism to go through, and then it will go back to a lock state. Also, they add more transitions like these two. So basically, while this machine is locked, you can push as many times as you want, but it will be in lock state. Nothing else will happen. Push action, in other words inputs, will do nothing unless you put a coin. Also, they specify that during the unlock state you can put as many coins as you want, but the machine will be in unlock state unless you push these bars, and then it will go to locked state. If you need more information, you can read this part. So this part describes it very well. But for now, I want to jump back to my slide. So in the slide I showed you before, we have a chart, and in here let's focus on other details that I didn't cover last time. So during the idle state, we can listen to all of these buttons to be pressed, but we will ignore the down button because we don't have anything. But as soon as user clicks left, we go to this state. And inside of this state, you see that we are interested only in key up event, and we will listen only key up on this button. And as soon as we do that, we go back to idle state, and the same for the other one. So the idea is that we have inputs while we are in a certain state, but we will ignore some of those inputs and react on other ones. So for example, in idle state we listen to 3 buttons but ignore this one. In this or run left state, we ignore all of the events except key up event for a certain button. In run right we listen to right button, in left we listen to left. If we click up during idle state, we go to a jump state and we run jump animation, but the idea is that while we are in this state, we ignore all of these inputs, and that gives us more safety in terms of the code, because we don't need to overpollute our code with if statements and different things. Okay, let's switch to the VS Code and add our state machine and also add our abstract state. For a state machine, I will create a class state machine, and in constructor I will define a target. So the target object, it's an object that will be passed around the states and will be in state machine, and the state machine with its states will control this target. So inside of the target object it can be anything. In our case it will be a hero. I will save it to a machine property. Then I will define two properties for states, for a current state and previous. By default we don't have anything, so they will be undefined. I will create a getters so we can get the target and the states. Next thing, I will add a method, a public method, which allows to change state to next state. So we can just say a state machine dot change state to, and we pass the next state. We will do a check. If the current state exists, we will exit from that state, and we will pass the callback that will be executed when the state finishes exiting. Otherwise, we will just call that callback directly. The callback itself will call the enter method of the next state, and then we will swap the states so we have information in a history, and also I will add a private method that will log data. So in console we can see from which state we transitioned to next one. So now let's define an abstract state that our unique states will use. For the abstract state I created a separate class. This will be an abstract state. I call it abstract because each unique state must inherit the abstract state. I add a constructor, and the constructor will expect two arguments, name and the state machine itself, because the state machine will be passed along, and that is how our state will get the reference to the target object. We will see that in an implementation of the states. I will save those two variables to a properties. Also, I will create getters to get the values. The next thing is to add an enter state, because each state should have enter method, and we will call that method from the state machine when we want to enter the next state. And exit state. Exit state expects the callback. We don't need that for enter state because we enter a state right away, but we need unfinished callback to know when the current state finishes its actions during the exit phase, so then we can enter next one, because we cannot enter the state before the current one finishes all its stuff. Okay, that was all what we need. Let's test it on some mock data. In my index.js file, I will create a fetch data state that extends abstract state. Then I will add a constructor that defines that I expect the state machine, and I will pass it along in a super, also with the name of these states, so we can use that for debugging. I override the enter state. If you remember, in abstract state we throw errors. That is why I call this class abstract state, because I can define all of the methods my application expects from this class, and it should work. Of course it will throw errors, but that will mean that the class that inherits from abstract state must override the methods. On enter, I will fetch the data from JSON placeholder API. Then I will parse the response, and the final state will be for me is to change state to next one. I will define this class in a second. On exit state, I just call my callback. There is nothing I can do on exit state for this class. But if I had something else, maybe one more asynchronous operation or something else, I would do that first, and then I would call the unfinished state. Now let's define this class. So it's process data state, and then it extends the abstract one. I do the same thing, but in this case I say that this class expects state machine but also data. This is what I do here, and this is how you can pass data along in different classes, because the state machine has a target with different services or other things, but you also can pass additional data. You can do it via state machine, just appending the data to a target, but that is not a good thing to do, because target should be a specified value at the start. And the data, this is the additional data I can put. So you see that I save this data here. On enter, I will just log it and I will exit this state. Here I will create my state machine. So target by default is just an empty object. Next, what I do, I say state machine change to this state. And then I will also hide a hero. Let's switch to the browser and see what we have in the console. I will run this with a live server. So here, if I refresh, you will see that the state was changed from the undefined to fetch data. When we fetch the data, we logged it. And then, so this log actually was from this state. And then we see logs from the state machine that we changed the state from fetch data from the previous class to process data. Let's see, if I switch to slow 3G, you will see that the logs will be shown with some delay. That will show that actually some time passed between two states. Okay, cool. So the idea is that what we can do, we can create a state, and inside of that state we can do the things we need and then ignore all of the other things, and in the next state we can do completely different things. Of course, that brings some overhead, because now for our project we need to create different states, and we need to extend an abstract state, we need to define classes, so it puts some overhead. So you need to create more and more boilerplate code and then populate that with your logic, but it will pay us back because everything will be separate and it will be easier to control, especially it will be easier to swap around. In the next video I will add all of the states for my hero, and you will see how we can utilize the state machine and abstract states for real things. We will see how we will rewrite all of this into states.